All right, so we're going to do the first one. You'll need to record this in your notes because it's not in there. So it's 4NH3 plus 5O2 yields 4NO plus 6H2O. So that's the reaction that we're working with. It's the same one that we worked with on the previous slide. And the question we're going to be doing first is what mass of water will be produced from 65 liters of O2 and 75 liters of NH3, both measured at STP. So when they give you two different quantities of two different reactants, you should automatically think of limiting reactant. So this is going back to stoichiometry, but now applied to gas laws. So since they gave us two different volumes, we need to figure out which of these is the limiting reactant first. Then we can figure out the mass of water that's produced when we mix 65 liters of oxygen with 75 liters of ammonia. And they're both measured at STP, so we can use our 22.4 in these conversions when we're solving when we're converting from volume to moles and that kind of thing. So I'll do the oxygen first. So we have 65 liters of O2. I'm going to convert that to moles. So 1 mole of O2 is 22.4 liters of O2. We can do that because it's at STP. And then I'm trying to figure out how much water would be produced. So 6 moles of water for every 5 moles of oxygen according to the balanced chemical equation. And I'm going to go ahead and solve this right now. We end up with 3.48 moles of water that could be produced from this quantity of oxygen. Now we need to figure out how much water could be produced from 75 liters of ammonia. So same process, 1 mole of ammonia is 22.4 liters of ammonia. Still solving for water, so it's 6 moles of H2O for every 4 moles of ammonia according to the balanced equation. Multiply and divide, and we get 5.02 moles of water. So since this is a lesser quantity, that's the maximum number of moles of water that could be produced when we have 65 liters of oxygen reacting with 75 liters of ammonia. So oxygen is our limiting reactant here, and those are moles of water. The question is not asking for moles of water, though. It's asking for mass of water. So we need to plug in or plug in 18 grams. Yes, we need to convert it to grams. So I'm going to take 3.48 moles of water and convert it to grams. So 1 mole H2O, 18 grams of H2O. And we get 62.7 grams of H2O. And that is our final answer for the first one.